the recording. So welcome to another session of 42 Wolfsburg knowledge sharing. This time we're going deep in two dimensions, both automotive as well as open source. Perfect cocktail, as many might say. We have Olli Hartkopp with us, one of our fellows from the earliest days, even before the fellowship program existed. We got him on board. So thanks, Olli, for contributing. Olli is working at Day at Volkswagen, promoting open source solutions there and developing them, not only promoting them, developing them. But at night, he hangs out at the Markthalle in Wolfsburg and thinks with us about how to bring Canvas learning and technology into our space. So thanks, Olli, for joining. And let me take that opportunity to say that our fellows always speak for themselves. That's really part of the whole deal that we have. We want people to think freely and out of their personal expertise, and mostly engineering expertise, as we're an engineering and software engineering school. We don't want politics. We don't necessarily want business. We want the best technical solutions and the technical know-how of people. So please do not attribute anything that any of our colleagues say here to the companies. These are personal statements. And with that, I move to our second presenter, Harald Ruckriegel, who has a long background in automotive and software engineering in that space as well. I believe in BMW for most of the time. Now, more recently became the chief technologist for automotive at Red Hat, one of our partners here at 42 Wolfsburg. And I think complementing Olli's expertise quite nicely. And then thirdly, we have Lukas Bulwahn from Elektrobit, who we're really happy to have here contributing mostly in the discussion section, but maybe also jumping in with the slides as we go through. The setup is fairly straightforward. Olli and Harald have prepared a really nice slide deck. I've just asked them if they really want to go through 44 slides, because that's when the thank you slide shows up. So either they're really fast, because we were thinking to do about 30 minutes or so of a presentation, 40 minutes, and then definitely leave enough time for questions from 42 folks around the world. So without further ado, please, Harald, Olli, take over the screen and let us hear what you prepared.
Thank you very much, Max. So we thought that perhaps 42 slides fit perfectly to Wolfsburg 42. That was the reason, but well, let's try to make that presentation as much as possible interactive with you. So we thought about what could be interesting from an automotive and also open source or standardization perspective. So first we thought to deep dive into some industry drivers, short overview about some actual topics there from the experts. Then about standardization as most important driver for open source, but also other possibilities for standardization. I would say the more historical one or more automotive specific. We have there are two types of standardization, the classical approach with classical specifications there, classical standards, and then I would say the newer approach with open source there. And we prepared some deep dives. Olli has prepared a very good deep dive for an upstream downstream example with a Linux CAN subsystem. I have something from the Red Hat side, and then also we have some additional examples. For example, Lukas is also heading an initiative called ELISA. So if we have time, let's deep dive into that. And let's see how far we get there. So let's start with the drivers for automotive. What is important for automotive at the moment from an vehicle-related perspective, of course, it's a digital transformation of automotive. And within the digital transformation, we have four main drivers. It's often referred as CASE or ACEs, which are the first letters of these drivers: autonomous driving, connected cars, electrified cars, and also shared vehicles, mobility services.
Harald,
and that, yeah.
Allow me to interrupt you. I know you had shared your screen, but I stopped sharing your screen when we made the introduction. So I believe you're already speaking to those wonderful slides. Thank you.
There we now are. It's coming. Yeah, that's very good. That's very good. Okay, so I'm referring here to the left side as driver. Yeah, digital transformation with CASE or ACEs requirements. And that means that we also have a big need to get very new vehicle architecture, not only vehicle architecture, but also vehicle back-end architectures. In the vehicle itself, we saw there an evolution of new functions, rear back cameras or additional features, and that meant in the past that we had a very big growth of car components, providing then hardware plus software as functions to the car, and those are called ECUs. And we see there a consolidation and a change of architectures of these car architectures. And within that, because of big drivers like autonomous driving, there is a big need for a more centralized and more powerful compute unit in the car. So there is a big need for reuse and integrated software components. And that means, from a technology point of view, that there is also a need for more state-of-the-art technologies. We already have virtualization approaches in the car itself. Now we see state-of-the-art technologies like containers getting more common. And also combined with that, we have more open source in the car and also more Linux or other related technologies like that. So we see there a big shift or a need to bring in state-of-the-art technologies from the back end into the car itself. And also there is another driver that we have very heavy competition. Yeah, we have very new car manufacturers which bring a lot of own capabilities, software and hardware capabilities into the market. And we see that the traditional ones now also want to build own capabilities and increase the importance of software. We are looking here to both the left side here. That means we have where the car itself or customer touch points. We have our in-vehicle platforms, and these in-vehicle platforms cover topics like infotainment, digital cockpits, autonomous driving, quality management, whatever is in the car. We have ECUs then with those software applications using then operating systems, and then also boards from hardware providers. Then we have the off-board part where we have on the complete right side then typical classical software applications, enterprise applications. The software is developed then for the car within engineering platforms or software factory approaches. Then it has to be brought into the car, yeah, through units, which are doing then fleet management, bringing over-the-air update software packages in the car. As an example, that's coming more and more through connected vehicle networks there. So this is an overview, left side the car, but it means also that you have a lot on the right side. And we are focusing now within the presentation more on the left side, on the software in the car itself. And here is an example. We see there an approach where we have see where the usage of more open source and commodity in the car. And Olli, I would hand over to you with that slide.
Yes, thank you. Yes, in fact, this is a slide I just stole from Jan Kiska, who's a friend of mine who is working for Siemens, and which was pretty interesting because we were both trying to drive open source ideas inside a big company. And what you can see here in this slide is really something which is the heart of open source, in fact, because open source, there are many things that can just be shared between different people, different companies, because they just do the same. But the tip of this iceberg, or of this triangle here, and the tip is the point where you are differentiating, and that's the big thing you have to think about when you think about open source, because when you just look on the most right figure, there is middleware, communication, domain-specific framework, all these things. You are not differentiating there to your customers. So the idea is really that you work together in so many open source parts where you are not differentiating, where you can just work together, bring ideas together, and especially build excellent things that a single company just wouldn't have the power to build and build all these things. And this is the main part where Siemens is going, and I think where mostly all companies are going. Even Google, they're having their Android, which is mostly open source, especially the Android open source project. But all the Google experience things, the applications, they are really proprietary. And this is something which you always have to take care of when you start a new project, which is really where are the points which are touch points that are customer specific, where you are differentiating, and where are things where you could just go and work together with other people. So this is, that's the point about this slide.
Thank you, Olli. So what idea is, we are talking about standardization and differentiating functionality. And the question is, how much of the stuff which is done for the car is competitive in differentiating, and how much is non-competitive? And I, as an example, have very extreme view. I'm a strong supporter of open source. For myself, I think around 80% is commodity and can be standardized. And that is the basis for open source or standardization. And then on top of that, you have a possibility to build your own differentiating functionality. And I had a discussion with Olli. It was really funny because I have the same view and brought that in, that the idea is, okay, on top you have a possibility as an ecosystem partner within Automotive, could be Volkswagen, could be another company, to build the differentiating functionality on top of reuse and standardization and specification or open source. So here are some examples of possibilities of standardization. On the left side, you see the more classical approach, which was already evolved successfully within the car manufacturers, within the supply chain, tier ones and tier two suppliers, to build standards to have a possibility to provide their systems within the value chain to the car manufacturers, which integrate them and then offer the complete product. And then on the right side, you see topics like open sourceware, community driven. And it's quite interesting how these pieces are fitting together. And we want to highlight that in our presentation. So let's deep dive in the classical approach, standardization through specification. So here are some examples of, I would say, classical specifications. For example, we have there the Automotive Open Systems Architecture, AUTOSAR, and that's a kind of middleware approach, which shows, defines how the different ECUs, so the software hardware units in the car, are working together and have interfaces. And I think it started around the year 2000 or directly after 2000, when some car manufacturers brought that up and informed their the AUTOSAR initiative. And I think over hundreds of participants, it should be over 300 stakeholders are part of it and are working together on these specifications. And I think the interesting fact is it's very specification driven. So if you print out all of these specifications and put that on the top. I think it's really high there. And so it had a classical approach called AutoSAR Classic. It has a more modern approach, adaptive, which is coming now more and more. And this is an example of the architectural standardization there. Another example is SPICE, or let's deep dive into the third one, ISO 26262. And that is a kind of ISO standard which has to be fulfilled, that a car is allowed to drive on the street. It's for functional safety, and it's quite interesting because it's not necessary from the government itself, but the car manufacturers use that to show that, or to ensure from their supplier network that these systems are safe, and also provide the safety to their car manufacturers. And in that, it's also important that the software and the hardware has to be functional safety certified. You need there a kind of certification body to ensure that, and give there a stamp. For example, TÜV Rhineland or TÜV Süd are some examples of these certification bodies, and this has to be fulfilled. So these are typical specification or certification examples. And then let's go to open source. The interesting fact is that open source approaches have to fulfill these standards because they are well established. And I think that's very balanced, because open source is very, well, I would say a modern and agile approach. And sometimes you think, okay, there are different bookends, but in the end, also the open source approaches have to fulfill these standards there. So if we are looking to open source approaches, I think it's important to mention, so you have millions of open source projects out there, and these projects are based on collaboration, transparency. It's about working together there, creating shared standards. It's more focused to implementation, but it also has documentation and other topics. But I think that's a little bit the difference to these traditional standardization approaches. These provide more specifications and more documentations, and these pieces are more aligned around code and implementation. So the idea is that shared problems create faster solutions, and also in the end more secure solutions out there. So the idea of open source is anyone can run software for any purpose. You share open source, the source code with it. Anyone can see source code and understand how it works, and of course, on basis on that, modifies that, adds own stuff, and use it outside of organization, and has the possibility to bring that back into the community. So it's also about sharing. So benefits are the creation of software can be achieved faster because you have many more people working on that. You achieve their freedom from vendor login because communities work on that, and they can take that from their own, but it hasn't a login and hasn't an IP correlated to that company. And also you have more possibilities to scale and develop there, because there's more talent available, and more people are working on that in these millions of community projects. So there's also quite a diversity there. There are, of course, also some challenges in these approaches. So one of them, I think Olli, I, and also Lukas, we have these challenges. Well, senior leadership isn't convenient with these approaches, so you need to convince them. And also some of the units aren't often used to these ways of working. I would say the legal departments in companies, but also purchasing is a typical stakeholder there. And where the IP has to be clarified. Yeah? So the ownage of the stuff. And it requires also some maturity to work with communities. And also it's not only consuming, it's also giving back. So it's not only downstream, yeah, taking the stuff, but also upstream, bringing back code and then your own changes. So I think important basis also for open source are these so-called software freedoms. These are very important. You can use this link here to the Free Software Foundation, where you can find that. So it's about the freedom to run a program as you wish it, to study the program, to change it to your personal requirements also, or company requirements, and the freedom to redistribute also the software code. But there are also some necessary, I would say, boundary conditions for this distribution, and that's up to how open source can be used. I mentioned it already. So there are two important aspects. There is the downstream part where you participate in communities, take the code, and then derive it to your own usage there. So that is meant by downstream. But open source lives from participation and then also bringing back to the community itself, and that's upstream. So I would say a sustainable participation is about having there a vital downstream there that the stuff is used, yeah, and then bringing back your own changes and improvements to the community itself. Here is also an important part of the different flavors of open source. So open source is about collaboration. And if you're using open source in your own projects or within enterprise environments, it's important to think about the collaboration modes which are used, or the contractual modes, how to use that and how to distribute that in the downstream approach. So normally you decide when you build your own community, are a part of a community, or using code from a community, what kind of license that is. And this gives their possibilities about different flavors of usage. So it means also that you have some freedoms about if you want to use open source in a very proprietary way, yeah, that is more of a left side. It's called permissive. At minimum, it is necessary if you're using open source here on the left side that you state clearly where the source is used from, the attribution about these licenses and where it comes from, yeah, that it's clear who created that and how it is derived. That is the left side here. And then to the right side, we are talking about copyleft. And copyleft means it's about the restrictiveness of downstream. And that means the more you are right here with weak or here especially with strong copyleft, that means that there are licenses which give you boundary conditions that you also have to publish that under the same license. Yeah. So there is a weak copyleft and then a strong copyleft. It's a little bit complicated, but I think it's important that there are different flavors of licenses, yeah, where you can build your own stuff and build your proprietary software, or there is a need that you also have to publish this software. And I think that is very important in the usage of open source. Good. So there are some typical licenses like Eclipse Foundation, or there are other initiatives, bigger initiatives. A good example is Linux Foundation. but then within that, every project can choose about the right license. Good. So let's jump further on. And I would say let's deep dive in terms of time directly into your example, Olli.
Yeah, okay. Thank you, Harald. We'll just ask you to just drop for the next slide and thing animation probably. First, go back very short. First, very short addition to these things, because I think I've been both in both sides, so either on ISO specifications and also in open source specifications. And in my opinion, when doing things in open source specifications and creating standardization there, the product is much more together with the customer of the product. So I would say even the developer who is using your component is a customer of this product. And in my opinion, especially in open source communities, you are very tight with your customer, because people say, okay, here's an error or here's a new feature I need. And I think this is very agile on the first side, and also things are just evolving from both sides. And I think this is pretty cool in open source communities. So now short deep dive into the Linux Canvas subsystem. And first thing I would like to show is that contribution is not code drop. So there are different things that big companies sometimes say, okay, we make this public and just drop it to GitHub or something, but you really have to take care about your code. Another thing is what happens if the code base is increasing and also the community. So you have to take care of these things. And then I would just like to show how the Linux kernel release train works, and also how these, for example, security issues are handled there with a very short example. Next, please. So this is a rough overview of what is currently implemented in the Linux kernel for the CAN bus subsystem. So we have a protocol family PFCAN, which lives next to PFEnet, so for the internet protocol. And inside this protocol family CAN, there are different protocols. For example, you have a raw socket where you can just access raw CAN data. You have broadcast manager, which is something like for filtering, especially in automotive environments. You have ISOTP, which is used for diagnosis, for example, for unified diagnostic services. You have J1939, which is used, for example, in trucks and special control units. You have a CAN gateway, which can be used to route between different CAN interfaces and different other things. So what you can see here on the left side, which is inside the Linux kernel, is what which is just comes to you, for example, when you install Ubuntu Linux or something like this. And what you can also get is the user space tools. For example, on the top right side, the CAN utils, which are hosted on GitHub and also available in Ubuntu and Debian. These are the user space tools. So all these makes a complete ecosystem, and people just asking on every level of these things for improvement, for new ideas, for things. Next, please. So this is a short view of where we started in 2008, and I think Linux 3.6. I think we are now at 5.14. And so it's even far away. But today we have, for example, in the Linux drivers netcan, which is the below value, we have now more than 50,000 lines of code for the drivers. So starting with 169 lines of code. So you can see here that when you just created such kind of standard, people are really hopping on the standard and say, hey, cool, now we have a clear interface for our CAN hardware, and we provide a driver for this CAN hardware, which is especially very good on system on chip, on USB CAN adapters, on all these things. And I think this is really something where you can see where standardization also increases the support for so many CAN hardware today. Next, please. So this is how the code is really created in Linux. So this is on the right hand side. It's also pretty old snapshot I made there, because it's the starting of the Canvas subsystem, but the entire development is really done transparently. So you have a discussion of patches. So patches are it's a difference, it's a diff file to the existing code, and whenever you have something new, you have a difference to the existing code, and people just are sending patches, and you just answer on the mail. You just go into the point in the code and say, okay, this doesn't fit to the concept, or here could be some improvement on all these things. And this is a very agile development process where not only one or two people, but 10 people or people you've never heard from pop up and say, okay, I have a remark to this line of code. And this is very, very interesting how the review process, how the mind building process for new features is done on open source on these mailing lists. So some people say mailing lists are old style, but it's cool. And finally, you have really the upstream process via the maintainers, or even subsystem maintainers or subsystem maintainers. So, for example, the maintainer of Linux kernels, Linus Torvalds, this subsystem for networking is done by Dave Miller. And for example, then the subsystem for the CAN subsystem, it's one is me, the maintainers. And so it's very interesting that in the end, it's very hierarchic. And how the things are going in, it has many to do with trust between the people, between the maintainers. It is really a very interesting approach, which I would like to encourage you really to look into how, for example, the Git or the kernel development is done. Next, please. So this is a very rough overview of the CAN development process. So next, please. I think we can just put in the things there. So you have a current release cycle, which is 3 months. So you have 4 releases per year. And the development is split in 2 things. So you have a 14 days merge window where new things are merged into the main development on the mainline path. And you have about 10 weeks for the integration and fixes, where you usually can put the next on. No, you can where you just integrate things, where you see is there some fallout, are things working together, and this is the blue thing. And after you're done, then you create a new version, and then you have different periods how long this Linux kernel is maintained. So next slide, please. So here's now an example for it's just an example. Next, please. So the point is, even when the merge window opens, you put in all the changed code from the Linux next phase. So in fact, it's like from the idea of the first patch you put into the Linux next phase to having this in the mainline kernel could be something like 3 to 6 months. So in the end, when the merge window opens, and you put all the things from the Linux Next upstream subsystems into Linux kernel. Next, please. So when the merge window then closes, then you have these release candidates. So RC1, RC2, RC4, RC7. In this phase, you just fix things and fix the integration of all these new features, but you very seldom add new functions. So it's really like you want to settle down all these things. And yeah, next, please. And in the end, after this settlement of 10 weeks, something like this, then you create a new version. So it's a new Linux 3. whatever. And what you can then see with the release, you mainly also open the next merge window after 1 or 2 days. So next, please. And in the end, this Linux kernel then got some point releases. So these are the stable releases then that are maintained, sometimes only 6 months, but sometimes also for 10 years. So there are Linux kernels out there where people are maintaining and bringing fixes back, and sometimes also backport fixes to older kernels, so that even older kernels that are in production at some point are maintained, get security and bug fixes. So next, please. So one thing which is pretty interesting to me is when you have a security issue, because you probably know about the CVE database, common vulnerabilities and exposures. It's mainly a process to handle security issues. You have a public available database which assigns all these CVE numbers, and it's mainly a bug tracking system. Next. So first thing is, of course, where do you address the security issue? Especially for Linux, I can tell you, for example, we had a security issue in the Linux CAN broadcast manager, and there is a script where you can just say, okay, in this code, we have a problem, and you just ask with the script, who is the maintainer, or who is responsible for this piece of code, piece of whatever. And yes, mainly then you contact these people. Next, please. For example, in this mail here on the right side, so you get a greetings. It's something at 2 in the night, 2 o'clock in the night, and there you can see, for example, a mail which is going to security@kernel.org. You describe the problem. You probably also describe the affected Linux distributions. In this case, the Ben Hawks also had some attachments there, which called Stranger Danger 1 and Stranger Danger 2, very funny names. And I compiled and run them, and they just crashed my system with user rights, which really make me sleepless this night. So, because when you know that people just can stop worldwide thousands or millions of Debian systems or Ubuntu systems, this is, wasn't very nice. But the point is, when you have a security problem, then you just fix it. So it's can go to the next slide, please. So you create the fix, you distribute this in a small circle. The guy who usually detected the problem also approves then the functionality of the fix with this circle of the mails on this mailing list of the security@kernel.org, and all the distributions, for example, Debian, Ubuntu, Red Hat, they are all informed. And then finally you send a public patch. So on the right hand side, you can see my mail where I've just asked Dave Miller, who is the networking maintainer, what to write in my patch description, because integer overflow doesn't look so nice. When you have an integer overflow, it's really not a nice thing to fix. And he just said, okay, no, this is bullshit. Just describe what the patch does and say what it really fixes. So it's really, whenever you have a problem, from my opinion, it was very, very professional how these things just are handled inside Linux, how people are handling all these things, how so at least at the point where I sent the public patch, at this point, all the Linux distributions already had updated packages in their systems. And here you can see how professional open source works when you just see it once from the inside. Yeah, thanks. I think this was a bit from my experience. I just wanted to bring on the other side.
Thank you very much.
Ollie. And now, of course, it's going back to Harald, but time is ticking, gentlemen. You have to do the impossible and transmit the really interesting information in like maximum 10 minutes.
I think it's good. So we will make it in 5. Okay, so I wanted to add very a few about how open source based business models are possible. Because we've seen open source approaches, and we've seen where, with a great example like Ollie made about a community, a vital project out there, and how that is done. And I wanted to bring in a perspective. It's of course also my company is working completely on that model. So Red Hat is doing completely everything open source based. And it's quite interesting how that is functioning. And I wanted to give there in the last minute some perspective to that. So we've seen now on the left side some examples of open source projects out there and how that is done in a very pragmatic way. So you can be part of it, like Olli. It's quite interesting because everyone can participate there and everyone can drive these things forward. And the question is how to build their projects out there or provide there some stable approach. Sometimes from a Red Hat perspective, we describe this area with those open source communities a little bit Wild West. Wild West means you can participate, you can contribute, you can release some stuff. And it's up to you if you drive such a community, if you get more followers, more activities, and these things evolve to vital community out there, for example, like Linux communities there. And the interesting piece about open source is that you can use that. It's also combined with those licenses out there, but you can't urge Olli to provide their maintenance for that stuff, or or to get to Olli if there's a problem, a bug in there. So
of course you can.
You can, yeah,
but you can't urge me, yeah.
Exactly. And that is the reason why companies like Red Hat are existing, because our approach is that we are working on these communities and we integrate those together to open source based products and provide them within provide their additional security features and stabilization. And then in the end, the most important thing is to provide their maintenance. That means that there is a derivation of code, and it's also published in own communities, but you provide their maintenance for frozen versions, for example, for over 10 years. And that is a very important piece for enterprises like Volkswagen or other car manufacturers, because they have someone which provides them the stabilized version and also bring in new security updates into these versions then. Here is an example how that can look like. So typical within Linux, you have there different projects out there. So there are hundreds of different projects. And then to provide there a distribution out there which can be used, these have to be integrated there. I think, Olli, you also showed some examples of that. And here is an example, Fedora then, which is quite a big community. It has over 1.2 million users. Also Linux Torvald is part of that. And that is the community which integrates that into a stabilized environment. And as an example, what Red Hat does, it takes the Fedora open source, also works on that, but derives then an own product, Red Hat Enterprise Linux, which provides a maintenance with frozen versions for enterprise environments. And that is an example of downstream. That means you have their open source communities, and then you downstream that to Fedora as an integration product, and then Red Hat does again a downstream to a Red Hat Enterprise Linux. But of course, important is also to bring then the stuff back upstream. And and here is perhaps the last example which shows the vitality, and also that we have here some pipelines and also complex pipelines within these open source approaches. So we announced there to provide there or develop there an open source Linux for the car. And for that, we also created there some communities to be part of. And here is an example you see on the left side. You have open source communities. We have the blue side with Fedora Linux. And then we have another community which gives the possibility for early versions of the Red Hat Enterprise Linux and be part of that within a partner environment and bring in the requirements to that product. And then the Enterprise Linux is derived. And what we did for Automotive, we made there a special interest group of that so-called center stream. And then put up a separate stream for an automotive product. It looks a little bit complex, but I wanted to show there that you have there a lot of flexibility and build their own open source based projects and products on top of that with a viable business model out there. So I would say let's come to an end and discuss with you about the topics we had in the presentation.
Wonderful. Thank you, Harald. I think it's absolutely clear that you win the prize for the more beautiful slides, but that says nothing about the content, which was equally great. Lukas, do you want to come in quickly as you have monitored the chat? And thank you very much for answering questions and contributing on that matter. You have been part of the conversation before. Maybe an interesting perspective from your end, and then 42 students from around the world. Just for the speakers, there's folks from Sao Paulo, from Moscow, from various places. So you might become famous in Japan soon. But Lukas, do you want to comment anything? Otherwise,
I think I can give a quick conclusion to that. What
please go ahead.
So you've seen that we've touched on various fields. So we're talking about open source, we're talking about business, the business models, the business value, so purely economic questions. But we have also looked into technical aspects, development process, some things that Oliver has shown. How do they work? How does it work? How is work organized? How are things getting done? As well as questions on how do you build industry collaborations through standardization or through open source communities, and various fields on details on legal questions there. Now, and all that in the focus of the automotive industry. We could probably give yet a complete series of further discussions on each of those topics. And I can only advise you, if you think one of those are interesting, all of those topics can define your further career for the next 60 years if you want to be in that business so long. Each of those fields have experts right now that have been studying topics for 30 years and longer. And I think in the future, you can also get in any of those fields interested and learn more about it. Okay,
very cool.
Get to the questions.
Yes, you can find out, by the way, about Electrobit and what Lukas is doing by Googling him. You won't find a LinkedIn profile or superficial things like that, but you will find a GitHub link and similar in-depth tech expertise and profiles. Let me use the moment that I have the talking stick to also share, remind the 42 Wolfsburg students that our fellows are here to work with you, to meet with you. So if you find this stuff interesting, please reach out to them and see if they can guide your career and you can think about where to move next. But João Felipe, you have a question, please unmute.
Good afternoon, guys, from Brazil. I'd like to ask about the, if we have an increasing usage for hardware from appliances, and now everything needs hardware. So we have the cars, and there is an apparent lower priority for such hardware in cars. So I would like to ask if there is a focus from your company on optimization of that hardware so you can do more with less, and if so, would you think that can be addressed by the open source community, or there is a differentiating factor that you would develop internally, like you said in the previous slides?
Maybe this is a question for me. Yes, at least I think as you can see that, for example, Volkswagen is currently ramping up a complete new organization to make software. This is something which is needed because we are integrating so much software that we, for example, have to maintain currently maybe 3 or 5 Linux kernels in our car. And so, for example, open source could here, for example, be an approach to reduce the lines of code. So people are always talking about increased lines of code, but I think the point is we have to go for better maintainability, to decrease the lines of code, to have, for example, only one kernel version in the car at different locations. And I think there are so many things to do, and open source, in my opinion, really helps to bring these ideas together to see, okay, what can we do? How can we unify things? And open source is a really big opener, in my opinion, to do so.
Yeah, perhaps to add to Ollie's point, I think it's important that open source is also evolving better if it's already built on standards. So from my perspective, also standardization of these hardware environments are very important to bring forward open source topics like Linux in the car. Yeah, it needs a basic standard environment. And so what we are seeing is also we have some standardization efforts from a hardware perspective, because in the embedded sector, we see there are different kinds of ECUs and boards, and that's more heterogeneous than in the typical server environment. So of course, it's helping to standardize that, to bring also the software and the software-defined part and the software-defined vehicle to the next stage.
And if I may, we had a great chat with Blaise Agueras from Google a couple of weeks ago, and he was pointing out, as software is really soaking all over the place, right, in many computers or mini computing devices. I think what we always have to remember is that this is only a couple of decades old, and that over time, as software will become more mature, I think that transparency and evolvability and simplification that Ollie talked about will become a main interest, not to get the basic functionality done in the first place, right? It will become harder and harder in the security sense and evolve over time. Now, I have a question that I wanted to ask all the time, and nobody else is raising their hand in the moment. There's time for probably one more after me. So please, especially if you're an introvert and you usually don't ask questions in settings like that, we are a friendly crowd and we'd love to hear your question. If you are a woman and you usually don't ask questions when there's only male presenters, and I apologize for that, please feel encouraged to come forward and ask a question either via chat or by unmuting. So you've described the classic distinction between standards and open source. Now, I would argue that in the internet world where I come from, with Google and IETF and these kind of sorts, they talk about open standards, and also the way that these standards are propagated are quite different than in the more traditional IEEE or DIN and ISO environments, right? You agree that this is a good version, and then people adopt it or they don't, right? You always have to keep downward compatibility. Some other aspects come in that make it easier, I think, for the environment to participate and take them up. But I'd love to hear your perspective on open internet standards and how they might or might not be useful in an automotive context.
So maybe very quickly to understand the differences that these industries basically face. So I think the internet companies and also the standards around internet technology, right, are in an ecosystem where you had very many companies being active and with very different sizes, where you had very many small companies that that were relevant in some sub part of the stack. In the automotive industry, we have a different ecosystem, or traditionally had a very different ecosystem. The supply chain is quite deep, so you usually have 2 to 3 companies being involved to really get one ECU running. But you have quite a low number of software developing companies in the automotive industry. So talking about really 50 to 60 companies very throughout the world that contribute here. And in that sense, it was possible in AUTOSAR, and I think it still is, to actually form a consortium that includes everyone. Maybe a few are not in there. Maybe Red Hat isn't there yet because they come from a different world. But all the companies that have been in the automotive industry in the past have joined those consortia. And hence it's basically the same.
Thanks, Lukas.
Other than that, it's really standardization through consortia.
You're describing the current status, and I'm trying to describe where we could go, or whether it's desirable or inevitable, as I would argue in the chat. I think that the internet world and the mobility worlds are colliding, and that there will be many more players using the type of standards, especially when we talk about V2X and things that have to do.
You already touching a pain point of the AUTOSAR legal contract, and that's actually something that the discussion around adaptive AUTOSAR made visible, I don't know, 5, 6 years ago when I was in there, that if we want to employ technologies from the outside within AUTOSAR and contribute back, you need to open up. And there are discussions among lawyers in the AUTOSAR consortium how to drive that forward in the next years. And if you know the automotive industry, that means decades.
Yeah, lawyers talking about the future is seldom a good idea. I'm terribly sorry, we're running out of time. I think, as expected, the discussion is juicy, and I hope I can win you, the audience, and the speakers back for another session, maybe in 4 weeks or so. Let it sink a bit, let people discover some fields, and then maybe we can make it a bit more of a conversational, a workshopy, smaller meeting. But this was really great. Thank you so much, Harald, Olli, Lukas. It's great to have experts like you around to work with our 42 students and hopefully produce some really useful content for the next generation of software engineers in the automotive sector and far beyond that. With that, I'll close the meeting a little bit over time, but I think still viable. Have a great evening in Germany, and enjoy the rest of the day if it's tomorrow or other around the world. Thank you.
Thank you. Bye.